You may have heard the theory that it is possible there are multiple universes where you exist in each one, but live a different life and make different decisions, resulting in a totally different outcome in each universe. We know this as the multiverse. But from where did this idea for multiple universes come from? Today we are going to confront the idea of the existence of a multiverse, as recent discoveries in physics and astronomy could point to their existence. So let us start. Have we finally found an evidence for a parallel universe, or is it something stranger we cannot comprehend? The universe that we know and exists in all began with the Big Bang, which expanded faster than the speed of light in a growth spurt called the inflation. And for as long as there has been a universe, space has been expanding ever since it came into existence 13.8 billion years ago. And it continues to expand. As far as we know, our universe is a single expanding blob of space-time speckled with trillions of galaxies that now stretches 93 billion light years from edge to edge. But beyond this limit, there are things which we cannot see that could be something more, or just an infinite expanse of nothingness. Our universe might be really big but also finite, or it could be infinitely big. Both of these things are possibilities. However, if the universe is infinitely big, there are only so many ways that matter can arrange itself within that universe, and eventually matter has to repeat and arrange itself in similar ways. If the universe is without an end, then it just might be home to parallel universes. With an infinite universe and only a finite number of complexions of matter, the way matter arranges itself will also have to repeat. That said, if a multiverse does exist, there would also be infinite versions of you and me. Other alternate versions of you might be doing the same thing you are doing right now, but some might be different. You might drive a BMW in one world but drive a Ferrari in another. But how could this be even possible? Because the observable universe extends only as far as light has travelled in 13.8 billion years since the Big Bang, the space-time beyond this distance can be considered to be its own separate universe. And if this is true, then there would be a multitude of universes existing next to each other in a giant patchwork of universes. Although the idea of parallel universes or a multiverse remains a mystery, with some calling the idea pure science fiction, it's still one of the biggest debates between experts, with some believing they exist while others disagree. Now let us take a look at why some researchers think they exist, and the unexplained scientific events that could actually be proof that parallel universes might exist. But first, we need a little bit of physics to understand everything. In quantum theory, an elementary particle such as an electron doesn't exist in a single state, but a multiplicity of locations, velocities, and orientations. One of those most famous logic-defying experiments in physics is called the double slit experiment. Waves that pass through two narrow slits will form an interference pattern on the screen. It doesn't matter if it's light waves, water waves, or sound waves. However, light isn't only a wave, it's also a particle called photon. Now here is where it starts to get weird. If you shoot a photon through the double slits, it still forms an interference pattern as if the photon was traveling through both slits at the same time. But here is where it gets more bizarre. Just by observing the double slit experiment, the behavior of the photon changes. Even if the photons are sent through the slits one at a time, there is still a wave present that produces the interference pattern. This is a wave of probability because the experiment is set up so the scientists don't know which of the two slits the single photon will pass through. But if they try to find out which slit the photon really goes through by setting up detectors in front of each slit, then the interference pattern doesn't show up at all. So, the scientists tried a variation on the double slit experiment and placed a special crystal at each slit that would split any incoming photon into an identical pair. One photon should create the standard interference pattern while the other would travel to the detector. But the strangest thing is that it still didn't work. This means that observing a photon can change events that have already happened. This is still one of the greatest mysteries of quantum mechanics. From a physics point of view, parallel universes are one of those imaginative and compelling theories that is very difficult to test, if not impossible. However, the idea of many worlds began in 1926 when physicist Erwin Schrödinger demonstrated that the subatomic world is fundamentally blurry. In our familiar human-scale reality, an object exists in one well-defined place. Put your phone on the table next to you and it's in the only place it can be regardless you are looking for it or not. But in the quantum realm, objects exist in a small state of probability and snap into focus only when observed. Before you look an object, whether it's an electron or an atom, it's not in any definite location. It might be more likely that you observe object in one place or another, but it's not located in a particular place. After nearly a century of experimentation, this phenomena is a core aspect of the physical world. It might sound crazy, and even Einstein struggled with that idea. What happened to all the other possible locations where the object could have been, and why should an object's behavior depend on whether or not somebody was looking at it? Someone was bound to come up with a radical explanation for this phenomenon. And in 1957, Hugh Everett III, while he was having a conversation with his friends about physics, it was then that he came up with a wild idea about how to fix this most puzzling problem in the quantum mechanics. Therefore, Everett imagined a multiverse full of different realms in which all the possibilities dictated by quantum mechanics could exist at once. He proposed that all possible outcomes really do occur, but that only a single version plays out in the world we live in. All the other possibilities split off from us, with each one giving rise in its own separate world. And everything that can happen does happen in some world. All of this sounded really bizarre, and no one would take Everett seriously at the time. But now, some physicists are considering the possibility of a multiverse. In fact, theories of cosmology, quantum physics, and the very philosophy of science have some problems that could be solved if a multiverse existed. Along with the idea of multiple universes created by infinitely extending space-time, other universes could also come into existence from a theory called eternal inflation. We already talked about how the universe we are in expanded rapidly after the Big Bang and inflated somewhat like a balloon. Eternal inflation theorizes that some pockets of space stop inflating while others continue to inflate, giving the rise to many isolated bubble universes. That said, our own universe could be just a separate bubble in the vast sea of space that contains other bubble universes like ours. There is even another idea which comes from string theory called brane worlds, which are parallel universes that hover out of reach to our own. This theory is centered around the idea that there could be many more dimensions to our world, besides the three space dimensions and the dimension of time. These three-dimensional brane worlds could exist in a higher dimensional space. So, is it possible that a multiverse or a parallel universe could exist? Well, wait for the second part to know about this. So, subscribe and ring the bell so you don't miss it out. Thanks for watching. See you in the next part.